Guys, today we are going to learn about fluids, and fluids comprises both liquids and gases. So they comprise both liquids, and also gases. So they are a very important part of nature, and you have seen fluids all your life without even realizing it. You may know what fluids is. Some people may say they are just liquids, or some may say they are just gases. But in truth, they are both liquids and gases. That's a pretty big misconception in people right there. So keep in mind of that. So one example of fluids you see in nature is water, and it's the water you drink, the water you see every day, and this is also a form of fluid. It's salt water, it's saline water. So that is another fluid. And here, can you tell in this example, can you tell me which are the fluids? And obviously you will tell me there is oxygen, and then there's a bit of CO2, then there's, try to guess it, helium. Yeah, there's helium in these balloons. So that's what it is making it float. And I will tell you why that is floating in a bit. So now let's head to some actual physics. Yeah, that's what I like to tell. Actual physics. So all fluids, you may have some people. You people have seen illustrations of solids, liquids, and gases in your preschool or in your middle school ages. So in these illustrations, these look like this. These are the solids, and they are packed very tightly. The molecules in them are packed so tightly that you can't even see what's in between them. And this is just an exaggeration, so you can see. And liquids are a bit different. They are a bit more spread out. And then finally we have gases. They don't have any direction in life, and they just wander without any aim. No one can stop them. We can do anything to them. Yeah. So that's gases, and I hope that you have an intuition of what it is. So let's dive into what we can do with them. So as I have told you, solids are packed very tightly, so they can't move that much. We can move them with a bit of force, but planet Earth can't. They are not that powerful. Yeah. Sorry, Corona. So solids can't move, but liquids and gases can. They are like jelly. They can move anywhere. So if you apply a little bit of force, even they will move. So I have told you these are liquids. And suppose I have a glass. And this is the container. And they have some molecules of water, and they are like this. And now I am asking you, what is the density of this fluid? If I ask you, you may say that you have already heard this term of density before. You will say, oh, that country is very densely populated, or that forest is very densely populated, or your brain is very dense. Yeah, like that we will say, because there are a lot of particles in this area. So I'll write the formula for density here. Density is, that's not a symbol for density. It's like this. We write it like this. And density is equal to the mass of the fluid divided by the volume of the fluid. So suppose if this glass is very large, it is the size of a city, it is the size of Manhattan. So this volume will be very large, and the mass will also be very large. So the density will be overall very it will be a bit mediocre. So suppose there is 1,000 kilogram of fluid in here. So we can write the mass as 1,000 kilograms. We can write it as 1,000 kilograms. And we can write the volume of this fluid as 20 meter cubed. So now we can simplify this a bit and write. We have the density of this fluid is 50 kilogram per meter cubed. So this is the unit for density. There are no special units for density. So this is the unit, and this is the symbol that we use to denote density with. Okay. Now let's what should we do? Let's derive something. That's my favorite thing to do. Just derive countless things, even things which are useless, because that's fun. We'll get that later. So we have one formula. We have density is equal to mass times, divided by volume. And now if we multiply both sides by volume, we'll get that density times volume is equal to mass. So this is one important concept that you have to remember. Okay. Now let's find something small. So let's draw a can out here. Nothing. Just a second. Let's draw a can. My can is not. Yeah. Okay. So we have a can here, and it is filled with some fluid. Let's say water, and we want to know how much pressure there is at the bottom of this can. Now this is an experiment for you. Fill a bottle with water and punch 2 holes, one at the bottom and one at the top. The hole at the bottom will spill out more water at a higher velocity, and the one at the top will not spill that much. And I will show you why. We know that everything on earth exerts a force of weight, and we know that the force of an object is mass times gravity. We know that it is mass times gravity, and we want to figure out how much pressure it is applying on this much area. So we can summarize what we did here. So we know that density times volume is equal to mass, and we can use that equation here. So let me grab some of real estate. Let me grab it. Okay. I was thinking a bit. So we know that pressure is equal to force divided by the area. So if you don't know this, then it's a good thing to remember, and it is pretty easy. So I'm going to do a small recap of what it is. We have a nail here. And if you take a hammer and try to put this in this block, it will be pretty easy. But suppose we don't have a nail, and instead of that we have a brick. A brick is pretty strong, but you will see that it's not that strong. So we have a brick here, and if we try to plug that thing into our wall, our neighbors won't be happy, we won't be happy, our electricians will not be happy, the world will not be happy. So we can't do that. So we are using a nail, and the reason we are using a nail is because it has less surface area. Its surface area is very less. So we will get more pressure here and it will dig down. So even if you apply a lot of force, if the area is bigger than that, our pressure will be very less. So that's a short introduction of force. And now let's look at pressure. So we know that pressure is equal to force divided by acceleration. So we know that force is equal to pressure divided by acceleration. And now we can use our density times velocity, density times volume formula, which is density times volume is equal to mass. Now if we multiply both sides by gravity, we will get that the density times gravity times volume is equal to the force that is exerted on this area. The force that is exerted on that area. We will get that, and that's a pretty useful idea if we want to find the force of that area, but we want to find the pressure of that area. So we can use a pressure formula and find the pressure. We know that pressure is equal to force divided by area, so we can divide this by area. So what is volume of this can? The volume of this can is the area at the bottom times the height. The volume of this can is area at the bottom times the height. So we can replace this by that's not correct. Yeah, we can replace this and write here, just a second. So we can write here area times height. Now we can cancel both these areas and we will get the pressure at the bottom is equal to the density times the gravity times the height. And isn't that beautiful? I think it's beautiful. Some may disagree, but I agree. So approved by me, you can say it anywhere. So this is the formula for pressure. Formula for pressure at the bottom. So I hope you understood something from this video, and it may help you later in your life building ships or launching stuff into space. Yeah. So bye.